Hello, this is another kinematics question where we'll continue to try and answer these problems with a little more insight than you get in the average textbook. We've got a lorry moving along a horizontal straight road with constant acceleration, as we always do. Passes point A with speed u, 10 seconds later passes point B with speed 34, and it gives us the distance AB. So let's tabulate all of this. We've got our time, our displacement, our velocity, and our acceleration. The time is going from 0 to 10 seconds. We'll set our origin at the point A. So we've made a choice there about frame of reference. We can say that after 10 seconds, it's moved 240 meters. We don't know what the starting velocity is. We haven't got our V0, but we know it ends up at 34. And we don't know the acceleration. So let's just see what we can fill in on this table. And as we recall from the earlier videos, it's much better if we've got one end of the table missing than the middle. So in this case, okay, we've got velocity and acceleration missing, but we've got all of the displacement. And that makes things easier because we can say that the change in the displacement, so this 240 meters, is the average velocity multiplied by the time. So the average velocity must be 24. So our u must be 14. And then we can say that the change in the velocity is the acceleration multiplied by the time. So the acceleration must be 2 meters per second squared. So we filled that in pretty easily just by talking through it. And it's given us our value of u, which is 14. Now we want the time taken for the lorry to move from A to the midpoint of AB. Right, we've now got an unknown time, which we're looking for. Midpoint of AB is at 120 meters. We've still got the same acceleration. We've got the same u, but our v has changed. So we've now got something missing in the middle in our table, which, okay, we can talk through it, but you might remember from an earlier question that it's quicker just to go to SUVAC, because talking through it and saying what the velocity is with respect to the acceleration and the unknown time, and then doing the same for displacement in relation to the velocity, means we're just constructing s equals ut plus a half at squared. So that would be what we create out of our discussion of what all these terms mean. So we might as well just jump in and use SUVAT. It's a great time to use it when you've got some v's missing. So 120 is going to be equal to 14t plus a half of a, which is 1 times t squared. So we've got that quadratic, t squared plus 14t minus 120 equals 0, just to get it in standard format. That's going to factorize pretty easily because we're going to want, what, 20s and 6s. So t plus 20 t minus 6 equals 0. We want positive time, so it's going to be t equals 6 seconds. So yeah, this is a case where we've used both approaches. The start of the question, in part A, it was a lot easier just talking through it, and it gave us the acceleration, so that was also the start of part B. But then, because we had a velocity missing, let's jump straight into here. So yeah, mixed methods, but we're not losing sight of what these things mean, which is the important part with kinematics.